In inherited blindness, genes which are passed from one generation to the next are the primary risk factor for vision loss. This is in comparison to non-inherited forms of vision loss, where other factors such as age in AMD, diabetes in diabetic retinopathy, and fluid pressure in the eye in glaucoma are the primary risk factors. Inherited vision impairment may be caused by mutations or small alterations or defects in our genes. Genetic inheritance can be described as either autosomal or sex-linked. An autosome is a chromosome which is not a sex-determining chromosome. Sex-linked chromosomes are X and Y chromosomes, which determine the gender of the child. Inheritance patterns help us to predict if a family member is likely to pass on a mutated gene, which could cause vision impairment. An individual will inherit 2 copies of each gene, one from the father and one from the mother. An autosomal dominant condition will develop if one mutated gene is inherited from either parent. An affected child will have at least one parent with the condition, and a 50% chance of passing it on to each of their children. An autosomal recessive condition requires inheritance of 2 copies of a mutated gene, one from each parent. If only one copy of a mutated gene is inherited, this individual will not develop the condition, but will be a carrier. The children of 2 parent carriers will have a 25% chance of inheriting the condition. Males and females are equally affected by autosomal dominant and recessive conditions. X-linked inheritance refers to sex-linked mutations present on the X chromosome. X-linked conditions are more common in males than females because a male inherits only one X chromosome. Therefore, if a male inherits one mutated X-linked gene, they'll develop the X-linked condition. Females require 2 copies of a mutated gene to develop the condition, unless the X-linked condition is dominant. In inherited vision loss, gene mutations lead to dysfunction or degeneration of rod and cone photoreceptor cells in the light-sensitive tissue at the back of the eye, known as the retina. Cone photoreceptors are concentrated in the central part of the retina, known as the macula, and are responsible for central and color vision. Rod photoreceptors are more numerous throughout the remainder of the retina and are vital for low light vision and peripheral vision. Inherited vision loss does not necessarily mean total blindness, as the majority of people maintain some functional vision. Impairment of cone photoreceptors results in reduced central vision, but peripheral vision initially remains unaffected. Impairment to rod photoreceptors affects peripheral vision, resulting in narrowing of the visual field or tunnel vision, as well as reduced vision in low lighting, known as nighttime blindness. Determining the pattern of inheritance through genetic screening may allow for early medical intervention to slow the progression of vision loss. Treatment strategies including gene therapy, drug therapy, and stem cell therapy may offer an intervention against visual impairment. Advances in technology, including digital magnifiers, screen readers, and smartphone applications, have helped people with vision loss to continue to work and maintain their independence. Inherited vision loss may not be easily recognizable in those affected, but they may still require assistance. If requested, provide an elbow for guidance and draw attention to obstacles such as steps. By combining treatment strategies, advances in technology, and your help, independence and quality of life can be restored to those affected by inherited vision loss.